Picked me up at my home, took me to Saturday morning physics in Ann Arbor one day. He invited me to come here and talk at the Institute for Retired Professionals about it, where he gave a talk about the Large Hadron Collider. So what could the person in charge of finding speakers love better than a new member who likes to speak? So here's Fred Gluckson talking about dust from a comet's tail.
There is a handout here. You don't need it to appreciate the talk, but I suggest you might pick one up and take it home. It's quite interesting. Just a one-pager. And I'd like to keep this interactive if possible, so if you have questions or comments, just raise your hand or holler Fred, but please don't blow that whistle again.
If you get interrupted by somebody, I will.
It's at my threshold of pain. Sorry, this should have been running earlier. For those of you that have laptops, I hadn't used this for about a year, and the battery appeared to be dead, but I gave it a long charge, a long duration charge, and it woke from its torque cord, and seems to be as good as new. Yeah, 96%, okay. Okay. Oh, I gotta get rid of this first. This presentation is about the NASA Stardust mission, which was a very ambitious, in my opinion, mission, the first and only astronomical mission to bring materials from our solar system back to Earth, of course, other than moon rocks. This is an artist's concept of the spacecraft. You see the usual solar collection panels on the sides. What you haven't seen before is this that is the collector, and it's likened to a tennis racket. It unfolded from itself and raised up out of that dish affair, and it's ready to enter the debris from Comet. It's called Vilda 2 Comet. Upon its return to Earth, it came through the atmosphere like a satellite at full speed, and then it unfurled a parachute. The mothership went on, and it has further work to do, although it no longer has its particle collector. That is now here. This tennis racket is shown here unfolded, and here it's shown blown up in larger view, and also in the laboratory. It's comprised of little cubes of a material called aerogel, which I had never heard of before. Aerogel is perhaps the most interesting technological aspect of this mission, other than having flown 3 billion miles over 7 years and come within 150 miles of its target. I'm naive enough to be impressed by that kind of navigation. This material, aerogel, is a manufactured material with the lowest density of any known porous solid. It's derived from a gel in which the liquid component of the gel has been replaced by a gas. It's an extremely low density solid with several remarkable properties. Noteworthy is that it's a terrific thermal insulator, and it's finding additional uses in respect to that property. It's not a new material. It was first created in 1931. It's made from a number of different solids. Silicon is the most common one, aluminum is another. And it's a rigid, dry material, but it looks like smoke. And to prove that it's rigid, here it is supporting a brick, 5-pound brick. It weighs only 2 grams, this little smoky thing. If you press on it, it does not leave a mark. However, if you press harder, you can get a permanent depression in the material. And if you press even harder, what do you suppose it does? It shatters like glass. It shatters into a jillion pieces. And they're still studying its properties and finding new uses for it. Here, they're disassembling the capsule that returned to Earth. The Lockheed Martin Company was a contractor, and these scientists are removing the, what do you call it, the thermal shield, and accessing the innards, the electronics, the navigation, and so on. But the tennis racket is in the bottom. And here is what the outcome was. These are samples that were collected as this rocket flew through the thin atmosphere of Vilda 2 Comet. Here's the beginning of the impact. The gel is moving this way. It's moving at about 6 times the speed of a bullet. I forget what speed a bullet goes. But we get a fracture at the beginning, and then the specimen tails off into this track, and here it's found at the end. Here are a couple of more specimen tracks. I think this is the same as this. If you rotate it 90 degrees and flip it, you can pretty much get the same thing. Now, analysis is underway. There's a cadre of scientists worldwide that have received copies of these, samples of these. About 1 million samples were collected, but most of them were very minuscule. The largest one is 1 millimeter in diameter, and they're 25 millimeters in an inch, so that's about the scope of the largest specimen that was found. The data is still coming in, but here is some early results. I will say, and for those of you that are interested in the path, let's get rid of this text. And where's my delete? Oops, I didn't want to delete that. Let's restore. And
Switch the forward to the background.
yeah, I could do that. But this will work too. So I'm not going to go over this because time doesn't permit. But I'd like to give you some of the preliminary results. And watch your Science Sky Telescope, Scientific American, for subsequent results. But some particles contain minerals that form only at extremely high temperatures, temperatures that could not have existed where the comets formed, where we think comets ordinarily formed. If these minerals in the comets are from our solar system, then they probably formed close to the young sun and were transported all the way from inside the orbit of Mercury past the orbit of Neptune. However, there's the possibility that some of these particles formed in other stars or near other stars. And here's the last. One of the most striking outcomes of this, of a workshop where the scientists got together, were preliminary data suggesting that the comet is a mix of both stardust grains from other stars as well as materials formed in the solar system. In addition, they found, I guess I don't have it here, but it would be in that handout. They found many organic molecules. In fact, they were very surprised at how much organic material was contained in the stardust samples. So we may not be alone here, but I'll leave that for another talk. Questions, comments? Yes?
What element was presented the largest quantity? Any idea?
They aren't exactly elements. They're particles that are comprised of many elements, which we're still figuring out. But most of them are silicon-based. And there are some heavy metals in addition. Anybody else?
What's in there? Is this the probe that crashed in the Earth?
No, that's Genesis. That was Genesis crashed. Stardust
Yeah.
made it.
There was one that the parachute didn't open up and
I
it crashed.
remember that.
Yeah,
I didn't
yeah.
run across that in my research, but I do remember that, like you.
Yeah.
And so what was this? This was a different mission?
Yeah, this is a different mission.
Yeah.
The Genesis mission is the one that crashed, but they've actually returned, been able to obtain decent results out of Genesis. It just took a lot more work.
And they used that same material, the aerogel.
They used the aerogel, and they used much the same design.
Yes.
But in the case of Genesis, there was some sort of a problem, and it turned out that Stardust didn't have the same problem.
My recollection, which could be wrong, is that the other mission may have used this aerogel stuff, but they also used things like silicon wafers
Sure.
to collect some of the samples.
Well, you know, when you fly a mission like that, you don't know what you're going to get. So you have to prepare for a variety of materials. And this aerogel is excellent at grabbing small, high-velocity particles, but a bigger particle would probably shatter it like glass. Yes, sir?
I find it, I had not heard this finding that some of the particles appear to have been formed at high temperatures, and it's puzzling how that could be, because you've got all this volatile stuff on these comets. One would think that if the comet itself had been really in a hot place before, all that stuff would have evaporated or sublimed.
Yeah.
I'm wondering whether, and this is off the top of my head, right, whether an alternative explanation might be that while the comet was way out in the middle of interstellar space or far from the sun, whether there were occasional small impacts on it
I
of
would
stuff that
suggest the same thing. It could
buried itself in a comet
it could have accumulated
and
material
went to high
also.
temperature in their little micro collisions.
There's more on that subject in this handout. So have a look at that. And if you're interested, you can go to Wikipedia, which has very nice coverage. And as I say, watch your monthly magazines. Dave?
I think the answer about the high temperature grains is that the grains are older than the comet. What was the solar system made from? It was made from the collapse of an interstellar cloud. What was the cloud made of? Gas and dust. And those dust grains could have been made of high temperature rock.
good topic for you, Dave, or for somebody is the collapse of the gas cloud that led to our formation of the solar system.
I'm working on such a presentation.
Oh, that's great. That's
The
great.
problem is that there's a short version of the presentation, and I can tell you right now, the short version is nobody knows. That's the problem.
Another one I'd like to hear is if somebody wants to do celestial navigation and how they get this puppy to 150 miles from its target. Yes.
The Genesis probe actually didn't crash. It just tried to collect a particle 100 billion times too large.
Are there any other comments or questions for Mr. Gluckson?
Yeah.
Was this the probe? We're all familiar with the SETI at home thing. Where you
What?
Most of us are all familiar with that SETI at home where you use this, your computer at home to do this.
SETI at home.
SETI at home.
Oh, no.
I think this program was the same thing where they gave us information.
Oh, no, there was Stardust at home. Some of the,
Stardust?
yes, some of the data processing was done using distributed.
Really? Don't you need laboratory analysis?
No, the issue in Stardust was that they had the aerogel, and they took very, very thin slices. You can't imagine how thin they are. And then they scanned these slices, and those are the pictures that you actually saw. But they had an enormous amount of just data to look at. So unlike SETI at home, which was where you used your screensavers computation to do this, what Stardust at home was that you could be shown an image, and you could there was a little training thing where you would get to know what one of these interesting features might look like, and then you would get shown an image, and you would identify little spots. And images tended to go out to more than one person, and spots that got identified by more than one person typically were then tagged for follow-up research. So the deal is you had hundreds of thousands of images, and even grad students will not do certain things. So there's a similar distributed thing, not using your computer so much as your brain. There's Galaxy Zoo and Galaxy Zoo 2